Hello everyone. Today's topic is electric resistance and Ohm's law. Let us consider this wire. In this wire, there are so many fixed positive ions and there are so many free electrons. Right now, there is no potential difference applied. So, electrons are randomly moving. But if we apply potential difference across the ends of the wire, electron starts moving from negative to positive terminal. Now, when potential difference is applied and electrons are moving, they are colliding with fixed positive ions and colliding with each other as well. So, their kinetic energy decreases and their speed decreases. So, we can say fixed positive ions are obstructing these electrons to flow. Or we can say this fixed positive ions applies resistance to the movement of these electrons. So, this obstruction offered to the flow of current by the conductor or a wire is called as resistance. So, resistance is nothing but opposition applied by the wire to the flow of electrons. Now, what is the cause of resistance? Why is resistance coming into existence? There are two causes. First, collision of electrons with positive ions. Second, collision of electrons with each other. So, due to this collision, their kinetic energy decreases and their speed decreases. Now, very important note is resistance of a conductor depends on the number of collisions suffered by the electrons. That is, magnitude of resistance will depend on how many times electrons are colliding. More the number of collisions, more will be the resistance. Now, what are the factors affecting resistance of a conductor? There are four factors. First is material, second is length, third is thickness of the conductor, fourth is temperature of the conductor. Let's study individual factors in detail. First is material of the conductor affects resistance. Every material has different number of free electrons in them. Wherever number of free electrons are more, definitely resistance will be less. Different substances have different concentration of free electrons. Therefore, resistance depends on its material. Now, examples we have taken: silver, copper, lead, aluminium. They have very high concentration of free electrons. So, they offer less resistance. But substances like rubber, glass, wood, they have negligible number of free electrons. So, they have very high resistance. Second factor is the length of the conductor. Longer the distance electrons has to travel, more the number of times they will collide. So, more the length, more will be the number of collisions. So, a long conductor offers more resistance. So, resistance is directly proportional to the length of a wire or length of a conductor. Now, example, if length of the wire is doubled, radius we are keeping is same, the resistance will get doubled. So, double the length, double the resistance. Next factor is thickness of conductor. Thick conductor offers less resistance. Let's imagine we are taking two wires. One is having less area of cross section, that is a thin wire, and one is having more area of cross section, which is a thick wire. Amount of current which has to flow through both the wires is same. So, number of electrons will be same through both. So, definitely in case of a thick wire, there will be more space for electrons to flow compared to thin wire. So, in a thick conductor, electrons can flow easily as they have more space. So, thick conductor offers less resistance. Resistance is inversely proportional to area of cross section. R is proportional to 1 upon A. Example, radius of wire of same length is doubled. Then area of cross section will become 4 times. Why we are telling 4 times? Because if we are talking about a wire, cross section will be circular in shape for a wire. So, for circle, area is pi r square. So, r square means 2 square. So, area will become 4 times. If area becomes 4 times, then definitely resistance is reduced 4 times. So, resistance becomes 1/4. Next example is radius is tripled. then area will be increased 9 times. The resistance becomes 1/9. Next factor is temperature. Now, if we are increasing the temperature of any substance, then heat is absorbed by the molecules and kinetic energy of those molecules increases. If temperature of a wire or a conductor is increased, then heat energy is absorbed by the free electrons and kinetic energy of those electrons increases. So, random motion of electrons increases. Due to increase in random motion, number of collisions will increase, and more the number of collisions, more will be the resistance. So, resistance of conductor increases. So, more the temperature, more the resistance. So, resistance is also directly proportional to temperature. Example, resistance of filament of a bulb is more because when it is glowing, it is at high temperature as compared to when it is cold. Next, let's talk about the very important Ohm's law. I have taken a glass rod and silk which is already charged. Right now, charge is less. Now we are connecting them with a wire. So this electrons will start flowing, current starts flowing. Till what time will this current flow? Till the charge on both the glass rod and silk becomes equal, right? So right now there is a difference of potential, so current is flowing. But when potential difference becomes zero, that is charge becomes equal, then current flow stops. So in short, flow of current depends on potential difference. Now, if suppose I have charged glass rod and silk more, then definitely more amount of current will flow. So, amount of current will be more if potential difference is more. That's what is the statement of Ohm's law. According to Ohm's law, current flowing in a conductor is directly proportional to the potential difference applied across its ends. That means, more the potential difference, more will be the current flowing. Current is directly proportional to potential difference only when physical conditions and temperature remains constant. If temperature is changing, then definitely dependence of current will not be directly proportional to potential difference. Let us consider a conductor. We are applying potential difference equal to V. Then due to this potential difference, current I is flowing. So according to Ohm's law, current is directly proportional to potential difference. Now I am taking this I in denominator. So I will get ratio V by I is equal to constant. Now let us consider this constant is nothing but the resistance of that wire or a conductor. So V by I is equal to resistance. Let's take this I on opposite side. So we will get V is equal to I into R. Now let's come to unit of resistance. From Ohm's law we got V is equal to IR. So we got a formula for resistance R is equal to V upon I. Why to remember units? Let's give unit to resistance. Potential difference is measured in volt, division sign. Current is measured in ampere. So, volt per ampere is the unit of resistance. But Sir Simon Ohm did lot of inventions in this term. So, in honor of that scientist, resistance is given unit ohm. And ohm is denoted by this symbol named as omega. Looking at this, it is very clear 1 ohm is equal to 1 volt upon 1 ampere or 1 volt per ampere. Now, I want to define 1 ohm. So, looking at this, we can define. Let us define in an easy way. When 1 volt of potential difference is applied across the ends of the conductor, and due to that, if 1 ampere current flows, then resistance of wire is said to be 1 ohm. Let's see the actual definition. The resistance of conductor is said to be 1 ohm if 1 ampere current flows through it when potential difference of 1 volt is applied across the ends. The law which we have studied, let us verify it experimentally. For that, we need to connect a circuit. In a circuit, we have a battery. battery negative terminal is connected to a rheostat. Rheostat movable terminal is connected to a key, and key is connected to ammeter, which is going to measure amount of current for us. Then this resistance, instead of this resistance, you can connect a small bulb, which is actually going to be the load in this case. So positive terminal of battery is connected to the resistance, and voltmeter is connected across the resistance to measure potential difference. What we want to verify, that really current is changing when potential difference is changed. So let's first draw a table. Serial number first, then comes ammeter reading. So amount of current will note down here, amount of potential difference will note down here, and then we will divide and find out resistance. Now let's first keep our rheostat terminal at this point. Note down the value of current and potential difference in this table. From here we should change the value of resistance. Value of resistance increased, so definitely amount of current will be decreased and potential difference will be decreased. So we will note down those values. Again we will change the resistance. Again we will note down the values of current and voltage. Likewise we will fill in these columns, and then we will divide and find out resistance. So resistance value will come out to be constant. We will find out the average of this resistance, which will give us the value of resistance of this resistor. So this constant value tells us that ratio V by I remains constant. Now let us draw VI graph for this experiment. So potential difference on y-axis and current on x-axis. If we are plotting all the values here in the graph, we will get a straight line inclined to x-axis. This straight line shows that potential difference increases, current also increases equally. So here our Ohm's law is verified. Now let's find out the slope. An important board question is, which physical quantity is obtained by finding slope of VI graph? So let's answer this question. Slope is equal to change in value on y-axis divided by change in value on x-axis. Change in value on y-axis will be obtaining the change in potential difference, and change in value on x-axis will be obtaining change in current. So y-axis potential difference and value on x-axis current. So what is the ratio V by I called as? It is called as resistance R. So which physical quantity is obtained by finding slope? Answer is resistance. Now most important is limitation of Ohm's law. Ohm's law is obeyed only when temperature of the conductor remains constant. If temperature keeps on changing, then current is not going to be proportional to potential difference. So Ohm's law will not be obeyed. Now let us study another physical quantity called as conductance. Name suggests resistance means opposition to the flow of current, whereas conductance means allowing current to flow. So conductance is nothing but the reciprocal of resistance. Formula is conductance is equal to 1 upon resistance. A unit also very easy. 1 upon resistance, so 1 upon ohm. It is also named as Siemens, or you can simply write ohm inverse. Now let's draw an IV graph, that is current voltage graph. Here a board question is, which physical quantity is obtained by finding slope of IV graph? Here in case of IV graph, current will be on y-axis and potential difference will be on x-axis. Slope, change in value on y-axis divided by change in value on x-axis. So for y-axis we are having current, x-axis we are having potential. So we'll have I upon V. What is this I upon V called as? Can I write it as 1 upon R? And what is 1 upon R called as? Conductance. It's a reciprocal of resistance. So slope of IV graph gives us conductance. Now let's differentiate between ohmic and non-ohmic resistors. See, names suggest ohmic resistors means all those conductors which obeys Ohm's law, and non-ohmic resistors are all those conductors which does not obey Ohm's law. Next point is VI graph for ohmic resistor will be a straight line inclined to time axis, as we have seen earlier. VI graph for non-ohmic resistor will be a curve because current is not increasing in equal amount with that of potential difference. Next point is slope of VI graph is same for all the values of V or I because it is a straight line. But slope of VI graph is going to be different at different points. Examples of ohmic resistors are silver, iron, copper, nichrome, all the metallic conductors. Whereas for non-ohmic resistor, examples are junction diode, LED, transistor, filament of a bulb. We have seen the example of filament of a bulb. Temperature goes on increasing for a bulb. So, current is not directly proportional to potential difference. Thank you.